the talk. So without further ado, we're running a little bit behind. Let me introduce, if I might, Garrison Lovely, our first speaker today. Garrison is reporter in residence at the Omidyar network and author of the forthcoming book, Obsolete: Power, Profit, and the Race for Machine Superintelligence. He's previously published cover stories in The Nation and Jacobin, and other writings in the New York Times, BBC Future, The Guardian US, The Verge, Vox, Time, Thomson Reuters Foundation, etc. His work covers a range of issues in technology, politics, power, and Garrison's pieces have been translated into Spanish, French, German, Portuguese, and Esperanto. And they've been referenced in the New Yorker, New York Times, The Atlantic, Axios, New York Magazine, and ProPublica. So if I might welcome Garrison to the stage.
Thank you so much, David. Cool. So since I'm the first talk of the session, I want to start with some definitions and talk about what we'll probably be talking about later. So artificial intelligence is a contentious term. A lot of people have a lot of feelings about it. Artificial general intelligence is even more contentious. And we'll, I'm sure, get into that a bit later. So what I'm talking about when I talk about AI are systems that are powered by deep learning. These are systems that are multi-layered neural networks that take data, process them through algorithms, and result in a model that can generate outputs of some kind. And I think an important feature of these systems is that they're more like creatures than they are like programs. You know, software historically has been something you code, you write inputs, you can see the connection between them and an output. Somebody who's an expert in the language or engineering can look at the code and understand what it's doing. But with deep learning systems, like the ones that power ChatGPT, it's more of a black box. This is a famous, comparison use, where you give it some input, it gives you an output. You don't really know what's happening. There's a bunch of numbers, there's a bunch of math, and this makes it hard to predict how these systems will behave. And when people who are not super worried about AI systems in the future talk about these things, they're often saying like, well, we'll just program them with good engineering principles. We'll program them to do things that we want and not the things that we don't want. But I think that this is actually a very hard thing to do. And then I'm usually going to be talking about large language models. So these are the things that are the basis for the chatbots that are dominating the news cycles these days and things that people in this room probably use on a regular basis. And this is part of this broader category of generative AI, which includes these language models, includes image generation models, often voice, video, etc. And these are, a thing that became really popular and like borderline household names with the rise of ChatGPT, which came out just over 2 years ago. And the world has changed a lot since then. These models are a mix of next token predictions. So given a string of tokens or words, what is the next word that's likely to come? Combined with what's called post-training, which is a way of like tweaking the data to make it more useful for humans. And if you just do next token prediction, this doesn't actually work very well as a conversational, chatbot. And so you have to do this thing that's known as reinforcement learning with human feedback, which is using a bunch of examples that chatbot generates and then having humans grade them based on how much they like the examples. And then you go from there and you get a model that is conversant and won't respond to your question with another question, but an answer. And in the last few months, we've entered this new paradigm of quote unquote reasoning models. These take these existing models and add a layer of the model kind of talking to itself and thinking through a problem and then giving an answer. And I'll get more into this a bit later and why I think this is a big deal. And so artificial general intelligence is a thing that people love to debate. And OpenAI, the probably leading AI company in the world, defines AGI as a highly autonomous system that outperforms humans at most economically valuable work. This is not doing every single thing that matters. A lot of people like to distinguish this from acting in the physical world. It seems likely that we're going to have AI systems that are able to act as like remote workers far sooner than we'll have robots that can do everything a human can do physically. And then there's this second idea of artificial superintelligence, which is less well-defined, but often it's something like AI that is more capable or smarter than all of humanity combined. And some people think that once you have a system that can improve itself, artificial superintelligence will come in a matter of years, months, weeks, days, hours, minutes, depending on who you ask. And there is a really, really roiling debate around artificial general intelligence. It's also a confusing debate because there are three sides to it, in my view. On one side, you have boosters or accelerationists. These are people who are like, AI is going to be really powerful and it's going to be really, really good, and we should get there as fast as possible. This includes people like Larry Page, the Google co-founder, Richard Sutton, one of the pioneers of reinforcement learning, and Mark Andreessen, the venture capitalist. Another side is sort of the AI ethics, or people focused on immediate harms from AI. This includes people like Deborah Raji, Joy Buolamwini, some of the people in this room, I think, as well. And this group broadly is more worried about AI systems underperforming, but still being trusted with critical tasks, and might focus more on harms coming from like algorithmic bias, and is maybe a bit skeptical of AI being really powerful in the future and sees the like hype around it as a marketing ploy by these companies or something that benefits, these large companies. And then there's a third camp, which is broadly AI safety. People focused on catastrophic or existential risk caused by AI. This includes people like Jeffrey Hinton, Yoshua Bengio, who are two of the most cited scientists alive, who pioneered deep learning. Stuart Russell, people like Elon Musk, kind of, people like Sam Altman, kind of. I think the inclusion of people who are building this technology in this category is like a source of a lot of confusion for people, because it's like, oh, you think this is going to kill everybody, but you're also doing as much as you can to make it happen faster than everyone else. It's kind of a tense position to be in. I ultimately think that the AI ethics and the AI safety communities are fighting broadly on the same side, which is to have human values guide AI systems rather than the profit motive, rather than geopolitical competition. And even though AI safety is sometimes framed as like this behemoth compared to AI ethics, which has a lot less resources, that may be true in some sense. The real money and power is with the boosters, which aren't just the famous people I mentioned, but are de facto OpenAI and Google, and these massive companies that have enormous lobbying budgets, deep connections with Washington, and the ability to kind of block any regulation that comes their way. I don't want to talk about AGI as the thing. I like to focus on automating machine learning, research and development. This is a thing that is strictly easier than a totally general system that can do as well as humans at basically every cognitive task. It's also a thing that all these companies are focused directly at. And they're focused on this because it would be really, really valuable to solve this. AI researchers are among the best paid people in the world. This is also something that is already capable of being remote. There's a lot of data on how to do ML research. A lot of that is also stored in the heads of people at OpenAI and Anthropic and Google. And there's a lot of effort happening right now to kind of get that information out of people's heads into training data that can be used to make these models better. And why I think this is so important is because recursive self-improvement is where things can get really, really crazy. That's where AI goes from like, oh, this thing that is kind of like the printing press into something that becomes potentially just like the technology to end all other technologies. Again, this is very contentious, but I think the intuition is pretty clear, at least to me, which is that if you can build AI systems that can make AI systems better, and you can keep deploying resources, money, computing power to that problem, you can just keep feeding back until some ceiling, and we don't really know what that ceiling is. And so I want to lay out a cause for concern. AI capabilities are advancing fast. The time to human level performance across a huge range of tasks is shrinking. And these tasks are fairly diverse as well. And the speed of this progress surprised even people who thought AI would move fast. There was one study of super forecasters and ML researchers, and they were asked to predict how good AI systems would be at math benchmarks in like a year. And nobody predicted how good they would be. It was far better than even the most optimistic predictions. And I think this captures like why ChatGPT created such a moment and a zeitgeist. Some people are like, oh, we knew how powerful these systems were. This just gave the public a window into them. And others were like, I actually didn't realize how fast things had moved. And this is part of what prompted Yoshua Bengio to speak out about the risks from advanced artificial intelligence. And we don't know where the ceiling is. Some people think that only humans can do the kind of reasoning that will generate new technologies, new ideas, the kind of improvements that you would need to recursively, bootstrap or self-improve. I'm not sure. I think that people who have mostly said, AI can't do this or will never be able to do that have been wrong so far. And there are some things that still can't do. There are still problems like hallucination. There are things that we don't know the solution for. But in general, I think betting against AI at a high level, continuing to advance, is a losing proposition. And there used to be a line, if you wrote about AI or read books about AI a few years ago, which is like, AI is narrow. Deep Blue can play chess, but it can't play checkers. It can't write a poem, review your essay, or give you advice. That line just doesn't apply anymore. These systems can do kind of everything, not always super well. But this is like a remarkable feature of the world. And it's kind of surprising that just something as basic and simple as like taking all the tokens that came before and predicting the next one can result in something that can do this huge range of tasks. There's more to it than that, but it's still just kind of this amazing fact. And it was a way of taking all this data we had on the internet and turning it into something useful. And I think that this progress is actually increasingly invisible now. There's a claim that like AI progress has been slowing down since like GPT-4 came out about 2 years ago. And models kind of clustered around that level of performance. There were no big breakthroughs of that size. But I actually think that really like progress in writing, the things that people use these models for every day, has been slower. That's true. But there's been this really, really fast progress on things like automating engineering and software engineering. So there's a benchmark of real life coding problems from GitHub. And the best models about a year and a half ago would get 4% of these right. That number now is around 70%. Frontier math was developed as a benchmark of extremely tough math problems that people in this room, maybe a few people would get some of these right. I would get none of these right. They're really, really hard. The best models got around 2% right a few months ago, and then O3 from OpenAI got 25% right. And then there's a benchmark of PhD level multiple choice science questions called GPQA. And these are designed to be ungoogleable. Human experts with access to the internet and a lot of time to answer these questions will get like 80% right in their own field. And the best models a year and a half ago would get maybe a third of these right. So a bit better than chance. Now the best models are beating humans at their own domain across every domain. And this is translating to real world outcomes. So there was a study with material scientists looking at how productive they would be if they were given access to the latest AI models. And it ultimately found a 17% rise in productivity. This is also accompanied by 80+% of the people using these models feeling less satisfaction with their work, which is a sad state of affairs where it's like, okay, maybe the economy grows like gangbusters, but humans are just in this smaller and smaller role and feel just increasingly useless. Doesn't seem great. And I think the most important benchmark of all of these is not that discussed. It's called RE Bench. and it's from Meter, which is a nonprofit that evaluates AI models. And they created a bunch of problems that were novel machine learning challenges that weren't in the training data. They were held out for these models. And they compared AI models to human experts. So people that work at top AI companies, people they recruited from online. And at 2 hours, the models beat the humans at these problems. At longer time frames, 8, 16, 32 hours, the humans overtake the models. But the models are better, even at 8 hours, than more than 1/3 of these human experts at these problems. And there's a really large gap between the models that came out more recently and the ones that came out even just a few months before. And this is not even the most up-to-date version of these models. Like O3 is not tested, Claude 3.7 is not tested. And so, yeah, I think this gets squarely at the thing I was mentioning earlier of like what happens if these systems are as good as the median worker at OpenAI or Anthropic at doing ML research and costs 10% as much, 1% as much to do an equivalent amount of work. Expert surveys, prediction markets, expert testimony, comments from industry leaders are all generally pointing in the same direction as well, which is that the time to human level AI is shrinking very quickly. In 2023, the largest survey of machine learning researchers said there was a 50-50 chance of human level AI at 2060. The next year, 1 year later, that dropped by 13 years to 2047. That survey for this year, I'd imagine, will have dropped by a similar amount, if not more. There are a bunch of other examples in this domain. And this is coinciding with a rise in autonomy of AI systems. This is making AI that can take actions in the world. And this is where a lot of business value lies. Like you want not an intern, but like an individual contributor that can go off and do a project for you that could take months, right? But this also creates some really, really hairy situations. New cybersecurity problems, just like what are the effects, I think Julian will talk about this, of having all these agents just going out and doing things. And if you imagine like millions, billions, or potentially trillions of AI agents taking actions in the world, and they're mostly trying to make somebody else money, you can kind of think about how this could go wrong. And broadly, there's so much more money and effort going toward making AI systems more powerful and autonomous than ever before. And all the stuff that we've seen in the last few years was a result of work that happened when the field was much, much smaller. And so it might get harder to go from where we are to human level AI, recursive self-improvement, but there's so much more effort going toward it that that might overtake it. It also might not get harder. It seems like, yeah, like I said, the skeptics have been largely not supported by the advances that we've been seeing. Why do some people think that AI could drive humanity extinct? I think the core intuition here is that we're creating a successor species. And the line I like is, gorillas should be careful about inventing humans. We've driven hundreds, thousands of species extinct, mostly by accident. This isn't out of malice. And an example Stephen Hawking uses is, imagine there's an anthill in the way of a hydroelectric dam that humans are trying to make. We build the dam, it destroys the anthill. It's not because we hate the ants, it's just they're in our way. We don't even think about it. And this is a way that people think about these AI systems relative to us, if they're sufficiently powerful. And some people are like, okay, just unplug the systems, don't give them that power. But I think that we're going to voluntarily cede more and more control to these systems as they become more useful. We'll do this because it makes us money, it gives us geopolitical advantage, and because those of us that don't do this will be outcompeted by those that do, provided that these systems are useful. And it might come a time when we just aren't in control of our future anymore, but there was no one decision that made it that way. It was this gradual disempowerment. And unplugging this system might be about as easy as unplugging Amazon Web Services. You can think about all the reasons that people would stop you from doing that, and then add some more. And why these systems might like turn against humanity is because instrumental convergence, this power-seeking behavior, might just be this kind of fundamental thing that emerges from intelligent goal-directed agents. Any goal you have a sub-goal of acquiring more power. You have a sub-goal of preserving yourself into the future. And there's some early empirical results with these models showing that some of these things do happen in experiments that are naturalistic. You'll see examples of deception, of models trying to exfiltrate their own weights, of them cheating at tasks, and being self-aware about doing this, using lines like lying, manipulating in their like scratch pad. It's early. We're only seeing small examples of this, and it's not in the majority of cases. But there seems to be a correlation between models that are more intelligent and more agentic and the ones that behave in this way. And I don't think you need to think about extinction to be concerned about AI. It's really tough to kill all humans. Yeah, it's a high bar. But I think it will by default concentrate power. And very few people who study this question think that society is ready for powerful agentic AI systems. There's no widely accepted solution to getting these systems to do what we want. And we don't even agree on what we want these systems to do. But right now, these questions are not being handled by society in a democratic process. They're being handled by unelected tech billionaires who have decided to do this for everybody else, despite many polls showing that's not what people want. And so whether you think AI could kill everybody, whether you think it's overhyped, if you think it will be powerful and powerful in the future, I think we all have a stake in getting involved in that conversation and distributing the power to everybody who will be affected by this, which I think is everybody, and yeah, participating. That's the talk.
Okay, Garrison, stay up here for a second. Julian's going to come. We're going to set Julian up with the laptop. So I'll ask you a question while Julian gets set up. So the sort of conclusion of the talk, you suggested potential openings for human decision making, maybe entering into a place where the direction of travel of this innovation